Hello and welcome to the Chanda Academy. In today's video we are going to solve an exercise where we will have to study a function fully. This function is a rational function, which means that this is the division, we can see the division sign here, of two polynomials. The first question of our exam is to find the domain df of the function. Let's remind the function going from the domain of x to R, and that given x will give x squared plus x plus 2 over x minus 1. The domain of the function df is the set of x's, so all x's, such as this makes sense. And when does this thing make sense? When x minus 1 is different from 0, because we do not want to divide by 0. This is absolutely forbidden, such as x minus 1. Okay, x minus 1 is different from 0, which is equivalent to x is different to 1. And so our set of x's, that is the domain of definition of x, df is equal to all the real numbers, but, so without, these things mean without, the only element 1, and we have solved our solution. And this is the same thing as all x's in R, such as x is different from 1. Same thing, same set. Okay, so these two things are the same. We will use this notation here. In the second question, we want to prove that for all x, of course, in df, f of x is equal to what? Is equal to x plus 3, x plus 3 plus 5 over x minus 1. Okay, x minus 1. X minus 1. So what do we want to do? We want to prove that this expression here is equal to this expression. And the easiest way to do so is to start from this expression and to put everything under the same denominator that we can see here. And hopefully we will find this at the top. Let's do it. So for all x in df, when x minus 1 is different from 0, we've got x plus 3 plus 5 over x minus 1 is equal to 5 plus x plus 3 times x minus 1, everything over x minus 1. So what we did here was to multiply by x minus 1 here at the top and at the bottom. We can do it because this thing is of course different from 0. Now let's develop. This is equal to 5, of course, plus x squared minus x plus 3x minus 3 over x minus 1. And this is equal to everything over x minus 1, x squared minus 2x plus 2. And this is, so this is a plus 2x here, sorry, plus 2x, so 3x minus x plus 2x, and this is the exact expression of f is equal to f of x. In conclusion, f of x is equal to this, of course, but going step by step, we can say that this is equal to x plus 3 plus 5 over x minus 1. And we have solved this question. The next question is to calculate the limit of the function plus the infinity, minus the infinity, and 1. So we will study the function on the left side of 1 and on the right side of 1. Let's do it. 3. First, in plus the infinity. The limit of f of x when x tends to plus the infinity is equal to what? This thing will tend to plus the infinity, of course, because x will tend to plus the infinity. And here we will have something like 5 over plus the infinity. And this thing will go to 0. This is equal to plus the infinity, this part, plus 0. And so is equal to plus the infinity. First one solved. Second one, what happens in minus the infinity? In minus the infinity, we will have x plus 3 that obviously go to minus the infinity when x goes to minus the infinity. X minus 1 will go to minus the infinity when x tends to minus the infinity. And so 1, 5 over x plus 1 will tend, when x tends to minus the infinity, to 0. And adding both, we will have f of x that tends in minus the infinity to, in x tends to minus the infinity, to minus the infinity plus 0, that is minus the infinity. In conclusion, lim of f of x when x tends to minus the infinity is equal to minus the infinity. Okay, for this part. Now, what happens? So our problem is in x is equal to 1. And we will try to see what happens just before 1 and just after 1. Okay? So in 1 minus first. What is the limit in 1 minus? If I've got my x-axis here and 1 here, this value is forbidden. Obviously, we will see that it goes to some infinity. But we can see what happens when we get closer and closer and closer and closer to 1 on the left side. And so this is 1 minus. And then on the right side, because different things will happen. Because the function is not continuous in 1. In 1 minus, what happens? Let's remind that f of x is equal to x plus 3 plus 5 over x minus 1. When we will tend to 1 minus, this of course will tend to 1 plus 3 is equal to 4. This will tend to that. And this will tend to 5 over 0. But what 0? As we are just before 1, we've got 1 minus minus 1. So just before 1, a thing a little bit smaller than 1, we will have something that will be negative. So 0 minus just before 0. And this thing is equal to minus the infinity. 5 over 0. So in the limit way of thinking, of course, we cannot divide by 0, but on the limit way of thinking, this will be equal to minus the infinity. And so the limit of f of x when x tends to 1 minus is equal to minus the infinity. For 1 plus, limit of f of x when x tends to 1 plus will be equal to, of course, 4, so the first part, and here plus 5 over this time 0 plus, because here we will have 1 plus this time minus 1, so something a little bit bigger than 1 minus 1, and this will give us a thing a little bit bigger than 0. And 5 over 0 plus will be this time equal, this thing is equal to plus the infinity. And of course 4 plus the infinity is equal to plus the infinity. And we have found our limit. We are done with the first part of the exercise. I don't want to do a video much too long for you. Come back for the second part where we will find the vertical and slant asymptote of C, the graph of x, and then study the variation of x. And the finality will be to sketch the graph C. Hope you enjoyed the video. See you, of course, in part 2. Bye!